Now, there you go. Hello, everyone. Welcome to another OllyGarden live stream. This is Wednesday, 3 p.m. here in Berlin. And today I'm going to focus on one topic that is that we've been covering in different ways and in different from different angles. And this is actually something that I realized when I talked to quite a lot of people, some of you including, and more concretely, I had a conversation with a company a few months ago, and they were asking me for some advice on tail sampling. So they actually sent me a message saying, "Oh, I see that you are somebody who's handled tail sampling before, so probably saw my name on the tail sampling processor for OpenTelemetry collector and related components." And then they messaged me saying, "Can you help us with tail sampling?" When I talked to them, what I realized was, yes, of course, they might have a lot of telemetry. They might have too much telemetry that they need sampling. But their actual biggest problem at the moment was the amount of garbage that they were collecting. My name is Juraci Kröhling. I'm a software engineer and I'm a co-founder here at OllyGarden. I've been doing telemetry systems for a while, and on every other Wednesday we have a live stream here at OllyGarden. At OllyGarden, we are improving the efficiency of telemetry pipelines, and one of the biggest issues that we see in telemetry pipelines is the amount of bad telemetry that we have there. And we are building solutions at OllyGarden to fix bad telemetry autonomously. Right. So first we tell you where bad telemetry is located, so you can send us data. We have an OTLP endpoint onto which you can send some data to us, some OTLP data to us. We analyze this data, and then we show you the insights that we found about your data. And then what we are building now, and what we are seeing some traction already, what we are seeing some results already, is then the autonomous part of the fixing. So we let Rose, our coding agent, go and fix the bad telemetry there. Now, what is then bad telemetry, and why, and what is the topic for today's conversation? So today we're going to talk about you don't have too much telemetry, although you might actually have too much telemetry, but this is a detail that we're going to cover later on. You actually have bad telemetry, right? So again, we were talking to a few companies in the past, and we saw this pattern repeating itself. Right. So we talked to a company just this week, and they were telling us, "Oh, we pay more than $300,000 a month for telemetry for a specific company and for a specific backend, and still they don't have control of their budget. They very frequently they look into their data and they look at the cost projection, and they have to take measures to ensure that they are still within the budget, right? So now, what they also have some measures there, like they drop 99% of the unformatted logs. So they basically say, if you don't care about your logs, if you are not formatting your logs, if you're not even paying attention to that, then it doesn't matter. You don't care about the logs at all. So let's just drop it. And I think it is a good approach, right? So you are dropping a lot of the data that is not useful to you. So you know at that stage that it is not useful. Of course, the best situation is always to not even generate those logs in the first place, right? But it's fine. It's good. So they are doing that. And we saw also other types of bad telemetry as well. We saw, for instance, some spans from a specific company that they had over 2,000 spans in one trace, and they were just saying, I cannot understand what's going on in there. Of course you cannot. I mean, with 2,000 spans in one trace, it's very hard to understand what is the actual transaction doing, what is the actual business of that specific trace, and what are the bottlenecks, what are the things that are happening there. And again, the idea is not, or the ideal is not to drop the spans, is not to sample those spans. Ideally, the traces, the solution is not to sample the traces or to drop the traces. The ideal is you have to look at your traces and select which spans are important. Right, so start by taking the spans from the boundaries, and then you add things in between. Of course, if you don't have anything at all, just flash the floodlight into your data, just visualize everything that is going on, and it's fine. Now, if you the moment that you do have this floodlight happening, that you have a lot of telemetry, a lot of things coming out of your application, then you start dialing down. So you start replacing parts of this floodlight with spotlights, right? So then you look at only the things that you care, only the things that you need. So let me share my screen because I prepared some numbers here. Let's see. Okay, cool. So this is the title slide. That's fine. So what is the right framing? So let's do a quick diagnostic here, right? So can your team answer the 3 questions that we have here about your own telemetry? And the first one is, what are we collecting? Do you know what you are collecting? Second question is, who owns this telemetry? So can you look at specific telemetry data point, a log, a metric, or a trace, and tell confidently who owns it? Like, who's the owner of this telemetry data point that I have? And third, is it worth keeping? Can you look at a telemetry data point and determine, is it worth keeping? So if it is worth keeping, great. If it is not, make a note. And then you go back step by step, shifting left to shifting left. And I actually don't like this term, but you go back closer to the source of your telemetry, and then you fix it. Of course, if you are part of a platform team, the only place that you can fix your telemetry is at the pipeline. So go and change the pipeline, fix the pipeline, and then you go left, and then you go closer to your application, and then you make your application not even generate that telemetry in the first place, right? So if you cannot answer those 3, you do have a volume. You do not have a volume problem. You have a governance problem wearing a volume costume, right? So you have a problem in actually collecting the right things from your systems. Now, so how does telemetry actually grow? So how do we end up there? So we end up there when we developers as well, we go there and we start adding like debug logs, and when we start doing things that make sense right now, but then eventually over time, that telemetry is not necessary anymore, right? So perhaps those client Kafka messages that we see, like the pings or the health checks from the load balancers and things, perhaps they make sense when we are developing the system in the first place, right? But then most of the time, those health checks, they're not necessary anymore, or at least most of them are not necessary. We still need a few of them, like just to know that they are still working, they're still there, because most of the time they're going to succeed. So you're not going to see anything at all. So instead of not seeing anything at all, or instead of seeing a lot of things that just say I'm fine, what we can do is we can say that, oh, I want only X% of the data, or only 1 or 2 health checks per minute, or things like that, right? So we don't have to collect every 5 seconds a new trace for our from our health check endpoints. Now, I mentioned one of the usual suspects. Let me see if I can change the slide here. Cool. All right. So yeah. So we have one of the usual suspects here in terms of bad telemetry, in terms of the volume of telemetry. And I just know that you have at least 1 or even 2 of the patterns that we're going to see here. The first one is health check floods, right? So again, this is actual data that we've been seeing from our users, from users of OllyGarden. Like in one case, we saw that 81% of the traces were just noise. Of the spans that we've seen are noise. They are Redis, pings, sentinels, or they are health check endpoints, or and only 19% of the spans that we are seeing from a specific user are actually business logic. Right, and if we look into that even closer, I think we may even reduce that number a little bit more. Right, so this is what we've seen from approximately 20,000 spans over a 5-minute sample from our platform. Right, so we saw data coming in. This is one specific user of OllyGarden. Again, this is not representative of everyone or every single user that we have, but this is one specific user. We looked into that this week, just I think yesterday or the day before. I looked at that data, and we ran some manual diagnostics there. So this is something that we were offering to our early users. So we ran some manual diagnostics. I do it myself, and then on that diagnosis, we found out that 19% only of the spans that they were sending were actually useful. Now, the second pattern are the duplicate logs. And I know that you have this problem, and I know you do, because most of you, or not most of you, but a lot of you have seen a LinkedIn post that I published a week or so ago about the log deduct processor, or a blog post even on opentelemetry.io and on OllyGarden's blog publication as well. So I published a blog post about the log deduplicator processor, and you seem to like it. And I know you do, because the pattern that I see is over 75% of the logs that we've seen from specific users of OllyGarden are exact duplicates, right? So without much effort, we can eliminate 75% of the logs from that specific user. So over 14 million log records is wasted per day. Now, on that post that I made on LinkedIn, somebody said something like, yeah, if storage is very efficient, so why do we care about filtering that data? And the argument is, efficiently storing garbage is still garbage, right? So you are still storing, you are still generating, you are still transmitting, you are still spending CPU and memory cycles and network and egress costs, and even storage, even if it is very efficient, it's money that I should not be spending. Should I not be paying for, right? So this is those are logs that I don't care about at all. And let's move on. And this third pattern that we see a lot is cardinality explosion. Now, high cardinality per se is not bad, but cardinality explosion is, right? So I'm going to cover that in a future blog post. I have a blog post almost ready on that topic already, where we talk about, what is the situation with the high cardinality, why it is not necessarily a problem, but the problem is on specific situations, we might end up having a cardinality explosion situation. And that is a problem. That is something that is bad. And in that specific case, we did find, so this is real data, this is real case from users. We've seen user IDs, offer IDs, national tax IDs as metric attributes. In one specific case, so national ID, national tax IDs. This is actually a dual problem, because it is high cardinality and it is also PII, right? So we have a PII leaking as a metric attribute, and we also have the problem of a high cardinality all in one. And I know that you've seen something similar to that before. Perhaps not as bad as, a PII plus high cardinality in one, but I certainly have seen it. So the pattern number 4, and again, I'm not against auto instrumentation, right? So it might seem that way. I'm not. I really like auto instrumentation. I like the thing that I like the fact that we can just add auto instrumentation to our code, and then we get telemetry. It's way better to have auto instrumentation in our code than to not have any telemetry at all, right? So it's good that we have telemetry. It's good that we have auto instrumentation. It's better if we have good telemetry. So worst case scenario, no telemetry, and then bad telemetry, and then good telemetry. Good telemetry is the ideal. But it's kind of utopic as well, right? So anyway, so auto instrumentation garbage. What we are saying is we do see, because of auto instrumentation, we see traces with over 2,000 spans, right? This is bad. Why this is bad? Because if we are capturing data at the eBPF layer, and this is something that I've seen as well on a demo of a product, people have a span that represents the lock and unlock of every single SQL statement that they run, right? And I don't need that as a developer. I don't need that, at least not for 99.9% of it. I don't remember in my career ever looking at a lock of a specific SQL statement. I don't. Perhaps you do. Perhaps you did debug a SQL query to that point. I never did. Of course, I did take care of full table scans and things like that, but I'm not at that specific level in details. Now, but that information is available when you do eBPF. That information is available to you by default, or at least was when I saw that specific demo. What else we have? So we have the invisible 83%. So when we talk about open telemetry, the service.name is one of the critical attributes that we should be having to at least attribute the owner of a telemetry. So if we don't have a service.name, we might still find who's the owner by looking at other attributes like the app from Kubernetes or kates.container.name or pod name and things like that. But if we are doing open telemetry, there is a specific name that we all agreed upon that we should be using to determine the origin, or the service at least, of a specific telemetry. So we don't know specifically which instance of the service it is. Perhaps we do, but most of the time, if we have only service name, we don't know which instance of a horizontally scalable service that telemetry is coming from. But at least with the service.name, we at least know what is the area that this is coming from. We know the team where this information is coming from, right? And in one specific user that we have, we found out that 82% of the telemetry does not have a service.name. And we are seeing a lot of sensitive data being leaked, right? So we talked about tax IDs, but we also seen JVM trust store passwords, or Kafka credentials, or authorization headers. One example that I used, that I give a lot to people when I'm talking about bad telemetry, is something that people don't actually realize. I ask them, do you use OAuth authentication for your applications? And most of the time they say, yes, I have at least one application where we do have OAuth, the OAuth dance, as we call it, right? So you have an application, redirects to an IDP server. The IDP server does the authentication of the user, does all the password checking, the multi-factor authentication, and so on and so forth. And then it returns back to the original caller. And the original caller, it receives an OAuth token in the query path. Now, this is all fine, part of the specification, no security issues there. The security issue is when we do auto instrumentation, it's very typical, it's very common for the libraries that are doing the auto instrumentation to capture the URL query parameters that are being received. And that lands into your telemetry backend. So that is your OAuth token, the real one that you are receiving from an IDP server. It lands at your backend, at your telemetry backend. Hopefully, that token is short-lived. So in 5 minutes, or perhaps even less, it is expired. Now, if it is not short-lived, then it means that anybody between you and your backend has access to that token. And what can they do with that token? They can replace that. They can exchange that token with another token, a longer-lived token, with an access token, right? So anyway, it should not be there. So don't do that. So this is, again, one of the situations of leaking sensitive data. So all tokens is one of them. And yeah, so and then we move to sampling. The sampling trap is what we mentioned as well already, part of this conversation here. Basically, when we select only a few things of garbage, we are still selecting garbage, right? So sampling garbage gives you a smaller pile of garbage. This is the main gist of the situation. Should we be sampling? Should we end up with a smaller pile of garbage? Yes, if you have a huge amount of garbage, yes. So first, by all means, reduce the pile of garbage. And then you reduce what is garbage from what is actually useful, so that you can then reduce the tail sampling, or you can reduce the sampling rates there, or you can increase the sampling rates there, so that you have more data, but then you have more quality data. And then you are actually happy to be paying the same amount of money to your vendor, but now you know that the data that you have there is high quality data. So you can send more high quality data from other services that you might not be observing today, or you might use more features from your vendors that you are not able to do because they're kept in the budget. All right, so how can we solve that? So instead of just talking about the problems, what can we do to solve the problem? So first one is, let's kill the health check traces. So this is one that we can remove from right now, right? So I think I shared already in a few blog posts how we can do cleanup of the health check traces. So if you cannot copy paste from this screen here, you cannot. You ping me, and then I can send you the link to that if you cannot find on previous contents, previous media that I shared. But in short, go to github.com/jpkröhling, my username, /hotel call -cookbooks. So in there, you are going to find a way to do health check filtering, not only by dropping 100%, as this example here is showing, but by showing you how to drop 90% of your health check, of your successful health checks, right? So that you still keep 10% or perhaps 1% of your health checks just for control purposes, while keeping 100% of the error traces as well. All right, so this is one way. The second way is using deduplication logic. So I shared as well as part of a blog post a couple of weeks ago how to do deduplication. Of course, you have to look at your logs. You have to study your logs to understand what are the duplicate logs that I need to remove. How is my configuration? But how you can do this is by using the log dedup processor in the collector, right? So if you are having trouble in coming up with a configuration for your log dedup processor, send your data to OllyGarden, and then we can tell you where is the garbage, how you can improve your data, right? Your logs. Cool. And you can also route logs by severity, right? So this is another technique that we're going to show perhaps at KubeCon. Let's see. We are still defining what we are going to talk about in one of the sessions at KubeCon and Observability Day in a few weeks' time. But one thing that you can do is you can also route by severity. One thing that I've seen successfully at other companies is if they receive data from dev, then dev goes to S3 buckets. It goes to block storage, right? So it goes to object storage, and because it's cheap, and you don't always need that data. You don't always debug on that data. You debug problems in production with data from production, right? So you debug data from dev based on dev. So you can send those dev logs to a cheaper storage, and then you keep your production warnings, your production infos, your production errors. You keep those production high value production logs in your backend, in your vendor, right? So with your vendor, and then you can do proper querying, you can do proper alerting. Why would you alert on logs? I don't know, but you can do that. But all the other logs, the low value logs, you can route them by severity, by attributes like development.environment.name equals dev goes to my object storage. All right, and the other one is strip the cardinality bombs, right? So let's try to clean up our data before it goes through the backend. Let's delete some of the keys that we know that they don't belong there, that like user.id, offer.id, transaction.id. Let's just remove them. Of course, doing that processing at the pipeline might be expensive, or it is processing that should not happen, right? So let's make it clear. This should not be in the pipeline. This should not even be generated in the first place. Now, if you are seeing that problem, if you are leaking, then you put your band-aid there. You fix the problem at the pipeline, and then you go back and fix at the source. How can you do that in the pipeline? OTTL to the rescue. You can use the transform processor with metric statements, and then you can do a delete key. So you can delete user.id, offer.id, and transaction.id, and things like that. All right. So I think this is pretty much it. So yeah. So fix our data. Fix our data. So first, start with the service name. Look at your telemetry and add telemetry, add service.name, for instance, to your telemetry so that you at least know who owns that data, who owns that telemetry. So if I see bad data coming from that service, who do I talk to? So this is one of the things that you need. Make an inventory as well. So have an inventory, or what are you collecting? Do you know what you're collecting? So make have an inventory of the top volume contributors of your telemetry so that you know where you should be paying attention to. Categorize. So what kinds of issues are you seeing the most? And then you tackle them at wholesale. It's easier to batch operations. It is true for the tasks that we do in our daily basis. It is true for sending data from one place to another. It is also true for this. So if you see that most of your services, they have health check issues, it's easier to fix at wholesale. Right, so you look at that and you do it at once, and you have a big effect on your data. And then you assess you assess the value. So when did it last help resolve an incident? So when did I actually use such telemetry data point to fix a problem on my systems, on my servers? And then fix at the source, right? So try to fix at the source. This is the best place to solve. If you cannot, or if you are leaking right now, if you have an issue right now, fix at the collector, right? And then once you have that data cleaned up, then you sample. Of course, if you are paying like for terabytes of data a minute or so, then by all means do a sampling right now, and then you do all of these steps, and then you go back to the sampling stage and you look at your sampling strategy, and then you relax a little bit, because by then, once you have high quality telemetry coming out of your systems, of your telemetry pipeline, then you can afford to sample more. Then you can afford to store more telemetry. Then you can afford to look at your data and see, you know what, instead of having 8 terabytes of data every single minute, I now have 1 terabyte of data every single minute. And then I can, instead of sampling only 20% of my data, meaning only storing 20% of my data, I can now store 80%, 90%, perhaps even 100. Perhaps I don't need to drop data at all. I can store all of my data. So yeah, this is, let me see. So yeah, so the next time that the budget conversation surfaces, the answer is not necessarily sample more or drop more data. The answer is really that you should be having better data in the first place. So let me go back here to this screen here. Cool. So thank you very much for attending. Thank you very much for listening. Thank you very much for watching this live stream. The idea here is really we'll be sharing these slides. I can share the slides, of course. I can definitely do it. So thank you very much for watching. I hope that by now you realize that you do have bad telemetry. You do have a lot of things in your telemetry that don't necessarily belong there, and that you can certainly apply some sampling strategy or strategies, plural, to your data, but you don't necessarily need that. If you have clean data, you might afford to store all of the data that you need. So then you can look at your data, and then you don't have to think, do I have all of the data that I need when an outage comes? Yes, you do. You don't have garbage. You just have data that is highly valuable. And if you need help in assessing the quality of your telemetry, then give us a call or send us a message here on LinkedIn. All right, so I'm Juraci, and I see you on the next OllyGarden live stream in a few weeks. See you. Bye-bye.